Hello everyone, in this video I am going to just talk about some very basic chemistry concepts to hopefully get you guys started and refresh your memory on chemistry a little bit. So we're going to talk a little bit about atomic structure in this video, and we're just going to cover the basics here. Like I said, this is more of a review type video, or if you haven't had chemistry, hopefully this will give you a general idea on some concepts. And we're going to start by talking about what is inside the atom. And typically when you see an atom, it's depicted to look, I don't know, something like this. This is your nucleus. You've got all these particles in here like this. And then out here you have these structures here. And typically it looks something like this when you see a picture of an atom. And what this all is representing is really not to scale, but it represents three major subatomic particles. Three major subatomic particles. And we're going to go over those now. So the first one is the proton. Proton is located in the nucleus, and these blue dots here, as you can see that I've drawn, are depicting protons. Now remember, again, this is not to scale. Not to scale. If we were to really draw an atom, the nucleus would be so small that you wouldn't actually be able to see it on this page. If that dot would represent the nucleus, it would actually be about 100,000 times smaller than that, and then here would be your electron. So just to give you an idea, and even this is not to scale, to give you an idea. So again, we talked about protons. They're located in the nucleus, and they're located in the nucleus with neutrons. So we have two central subatomic particles. That's my phone, sorry about that, guys. Turn that off. Okay, electrons are the third subatomic particle we'll be talking about, and these are located in orbitals. They're not in the nucleus. If you remember, they're outside of the nucleus. So what really is the function of these subatomic particles? Well, protons have a positive charge, and electrons have a negative charge. So they balance each other a little bit. We'll talk about shielding later on. And the neutrons don't have any charge. They have zero charge. Neutrons' primary function is typically going to be found in radioactive decay. And electrons are really, well, let's go to protons next, actually. Protons are actually going to be used to find the identity of the element, or in other words, give you the atomic number. And protons actually, in some cases, will also be affected in radioactive decay also. Electrons are really used for pretty much everything. Mostly what we'll talk about first is going to be different types of bonding with electrons, but electrons are used in all major biological systems. I mean, protons are too, but electrons have such an important role, and it's something that we'll be talking about quite a bit. Now, one thing that you also want to remember is that protons have an atomic mass unit of 1. Neutrons also have an atomic mass unit of 1, but electrons, we say 0, and you might think of how can something weigh 0? That doesn't make sense. Well, electrons don't actually weigh 0, but they're so insignificant relative to the weight of protons and neutrons that we don't even factor them into the atomic mass unit. Okay? So let's just look at a couple examples of how these subatomic particles can come into play with some very basic problems. we know that if we had an element, we'll call it X, that the element X has an atomic mass of A for atomic mass, and it has a number Z. This is how we can identify an element. So remember that X represents the element, Z represents the atomic number, and A represents the atomic mass. Okay, so if we know some of this information, we can figure out the rest. So for example, if I just told you that I was thinking of the element carbon, I can look on a periodic table and find carbon, and I will see that carbon is denoted with C, and I can say, okay, well, carbon on my periodic table, if you're looking at it, says that it has an average atomic mass of 12. It has an average atomic mass of 12. And the number for carbon is 6. Okay. Now what if I said instead, okay, well this time I'm going to give you a different bit of information. If I told you that the element that I was thinking of had an atomic mass of 31 average atomic mass units, would you be able to calculate the rest of the information? Well, if you look on your periodic table, you can see that the element that has an average atomic mass, if you round up, is going to be phosphorus. So you know that's the element. We know the atomic mass is going to be, I did this in the wrong color, sorry about that, guys. That should have been in green. The atomic mass is 31, and the element is phosphorus, and that's the 15th element. Now if I asked you, how many protons does phosphorus have? Remember that protons is the atomic number. So protons is the atomic number. So that, in other words, the protons is kind of like the identity of the atom. So how many protons does phosphorus have? 15. Because it's the atomic number, it represents the identity. How many electrons does phosphorus have? Well, phosphorus is not an ion, and if you don't know what an ion is, it's okay. But phosphorus has no charge. We have to equal this charge of 15. So how many electrons does it have? Well, it has no charge. So if it has 15 protons, it has 15 electrons. How many neutrons does it have? How many neutrons does it have? Well, we know that the atomic mass equals the protons plus the neutrons plus the electrons. But remember that protons have an atomic mass of 1, neutrons have an atomic mass of 1, but electrons we don't even count them because they're insignificant, so we won't even look at electrons. So we're really just focused on the protons plus the neutrons should give us the atomic mass, which is that number. We know that we have 15 protons. So 15 protons plus the number of neutrons should give us that number, which is 31. So we subtract 15 from both sides, and we get 16 neutrons. So we have 16 neutrons. So phosphorus has 15 protons, 15 electrons, and 16 neutrons. And we got all of that information just from knowing the atomic number. Okay, maybe we'll do a couple more examples of these. I think they're relatively straightforward. If you're having trouble with it, you can always practice with examples online, but I might do a couple more examples just to really hit the point home before we move on.